All right, good morning, Giants. So today we are going to start off with a little review. If you go to the next page of our packet, and we're going to start off, you'll see up here it says it's a review from 2.1b notes, what we did last week. So if I were you, I recommend pausing this video and giving these a try. Okay, I'm sure not all of you are going to do that, but if I were you to get the most out of this, that's what I would do. So right here, we're adding f and g together, our two functions together. So we know that if we add those two together, it'll be 4x here plus the x plus 10. And when we're doing addition, we can simply combine like terms. So we'll get 5x plus 7. And that will be our final answer for that one. Now the next one, same idea, except now it's g of x minus f of x. So once again, I'm going to put parentheses around them. X plus 10, remember, order does matter in this case with subtraction. 4x minus 3, now we distribute that negative in, and the x plus 10 will stay the same, so keep change change, or keep change flip, or distribute, whatever helps you remember it. And that becomes plus 3. And now we combine our like terms, so negative 3x plus 13, and that is our final answer. Right, our next one, g of f of x. So on this one, we are going to plug whatever f of x is into g. So g is normally x plus 10, so instead of that x at the front, we'll put a parentheses and just put 4x minus 3. Then don't forget the plus 10 at the end. And our final answer gives us 4x plus 7. Now, that one is very close to the first one, but it's not quite the same. Okay, so each of these, as the numbers and the letters get rearranged, is slightly different. If we look here at this next one, f of g, so like what we just did, except the other way around. Okay, so this time instead we're going to plug whatever g is into f. So it'll start with the 4. Instead of the x, we put parentheses. We'll put g in there, x plus 10. I got that from right here. Close the parentheses, and don't forget there's a minus 3 at the end. So we distribute, we get 4x plus 40 minus 3. And our final answer, 4x plus 37. Okay, our next one, g of f of 3. So on this one, we plug the 3 into f, so 3 goes right in there. So that'll be 4 times 3 minus 3. 4 times 3 is 12, minus 3, and we get 9, which now takes the place there, so now it's g of 9. So we plug that 9 in, 9 plus 10, and our final answer is 19. And now the final one. This one is slightly different than number 4. Very close, except that's a dot instead of like an open circle. So now we're going to multiply. So on this one, we'll do 4x minus 3 times x plus 10. And now we're going to FOIL. So first, we get 4x squared outside plus 40x inside minus 3x, and then last minus 30. Okay, and now all we got to do is combine our like terms, and we're left with 4x squared plus 37x minus 30. All right, so that was our review from 2.1b. Now down here, we're moving to 2.2 notes, okay? And here we're trying to decide, are these even, odd, or neither? So we look at this first one. That x technically has a 1, so odd, but this is technically x to the 0. So we have one of each, so that one's neither. We got a 7, a 3, and a 1. So all of these are going to be odd. On this one, there's nothing except 17, which is technically x to 0. So that is what we call even. And here we got a 2 and technically another x to 0. So that is also going to be even. Now, as we look at these pictures, to identify if these are even, odd, or neither, we need to remember back to the symmetry. So if you have to, go back to 2.2, look at the top. So we look at this first one, and this is symmetric over the origin. Whenever that's the case, that means it is odd. Okay, now this next one, it's not symmetric around the origin or the x-axis or the y-axis, so that one's going to be neither. Okay, and then this final one, that is symmetric over the y-axis, so that is what we call even. All right, so that was a little bit of review for us, and now we want to review these properties. So let me quick rotate my picture. So I need to rotate it there. All right, and now if we look here, yesterday we talked about some properties. Remember, our domain is always going to be brackets, because it always includes those endpoints. Domain refers to our x, and another way to think about it is what's the farthest left to the farthest right. Now for range, similar concept, and once again, always brackets, it's our y, except instead it's from low to high. And maybe I should put a point here. If you have colors at home, maybe try to use some colors so it's a little more distinct for you. But farthest left here is over here. Farthest right is over there. So we take the x values of those. Low to high, here's the lowest point. Here's the highest point. So we take the y values for that. Now our next one, where is it positive? And this occurs when it is above the x-axis. So above x-axis. So in our case here, it'd be this whole part that I highlighted in green would be considered positive, and also over here, that little chunk. Now the negative, this is when it's below the x-axis, okay? So in our case here, it's going to be this part in red, and also over here, this chunk. Those are both below the x-axis. And these sometimes will have brackets, sometimes they'll have parentheses. It just depends on the situation. Okay, so now flip it to the back of that, and we're going to take a look here at increasing. And increasing is any time, essentially, it's going uphill. So what I mean by that is right here, the slope is positive. The slope is positive. It's going uphill. That is increasing. There'd be another chunk right here, and it's increasing there. Now decreasing, opposite, it's going downhill. So if we read from left to right, wherever it looks like it's going downhill, that is decreasing. So right here, this chunk, now be careful. Where I have my mouse right here, this part, that is considered constant. It's neutral, it's not decreasing, it's not increasing, it is constant. We'd have one more chunk that is decreasing, and that would be over here in the red again. Okay, and now our x-intercepts, this is where does it cross the x-axis? Okay, so x-intercepts, in our case here, that would be 3. So it crosses the x-axis. And then the y-intercept is where does it cross the y-axis? All right, and then on our last one here, the max or the min. Now remember, those are our relative max and our relative min. So when it's max or min and relative is put with it, what that means is, What am I saying? I meant to say it's the local max and the local min. Okay. So our local, I forgot that word, local max, local min. So the local max is going to occur right here with green, and it occurs at the peak or the hilltop. And it always is going to go from increasing to decreasing. So do you see it was going up and then it was going down? Okay, that peak or hilltop is our local max. Our local min is going to occur at a valley. Now let me do this in a different color. So it occurs at the valleys right here. It was going down, then it was going up, so it occurs at that valley. All right, so that's all I got for you today. Hopefully you took notes and used some color on this. Keep in mind, this chapter, like all of them right now, is open note, so you will be able to use this to guide you. You just have to know how to interpret what these different things mean and interpret these graphs. Hope you guys have a great day, and let me know if you guys have any questions. Bye.